Hello and welcome to this live stream on electric vehicle architectures. I'm Nick Holt, editor at AMS. Just to set some context for this session, EV development continues at a really rapid pace, as I'm sure we're all aware of. And there's been a lot of focus around battery cell development and production. But in parallel to that, vehicle architectures and the platforms underpinning the various body types that we're seeing are also continuing to evolve as vehicle makers are striving to find the optimum balance between platform flexibility to meet changing market demands for new models, while also being viable for high volume production, and that's a key factor. So during this session, we're going to cover a few of these key topics. Platform choices. So it's creating a flexible platform that can meet a number of segment requirements. And unibody, we've seen that's been around for a long time. It's well versed, it's versatile, it's used in high volume production, and it's familiar. You don't need to re-equip, but it does need to accommodate a battery pack, and therein starts to add complication to the whole process. So we're going to be touching a little bit on that. Skateboard platforms, which similar-ish, but have become a bit of a byword. But we've seen different approaches to this. One key one at the moment is for LCV market. That's proving very popular for this kind of four wheels on the corner of a battery pack policy. It's very flexible and it can accommodate a lot of bespoke custom bodies. So again, we'll look into the pros and cons of what platforms, which direction is going, what trends are in there, and what the pros and cons of them are. Forming and joining. Well, one of the big stories this year, or last year as well, was around gigacasting. Tesla sort of made the announcement they were using these very large scale cast aluminium parts to minimize the complexity of their platforms and reduce the part count. But also gigastamping has now been developed as well. So this is accommodating steel parts. And we're going to look at, it's a new process and it can simplify the body shop operations and the vehicle structures, but it does require more processes for casting especially. So we're going to look at some of the options around that, again, some of the pros and cons, and some of the technologies involved in that. And that also brings up some joining options. Now, this is a sort of favourite one. We always go, is welding done? Is welding now on the decline, given that all the joining options that are out there, the joining solutions, are pretty mature now? And are we seeing a push towards other areas with laser, with rivets, with flow drill fixings? We'll find out what our panel think around those areas. And then materials. And again, it's one that keeps cropping up. Is steel going to be, is steel in decline? Is it going to be less used? Is more lightweight materials going to be coming to the fore to meet all the requirements of these EV platforms? And again, we're going to have a chat with our experts on that and see what they think and their insights from their work with their customers. So just before we get into the session proper, some information for the audience. I'd like to invite all of you to send questions during our session after some presentations. So please do send them to our panelists. They're waiting to see what you think, listen to what they're saying, and feed into the conversation. Be more than happy to hear from you. You can type your questions into the lower right-hand side of your screen into the chat box, and we'll read them there, into the questions, and we'll feed those through. And if you experience any technical issues, you can put those into the chat box, and our team here will see if they can sort those out for you. I'd like to start with thanking our partner for this live stream, working with ArcelorMittal on this, and we're very grateful to work with them. They're a great company, and we'll hear more from them in due course. I'd also like to introduce our panel of experts. We have, beginning with Paul Belanger. Paul's R&D Director at North America for Gestamp. He leads a team of body engineers developing products and new technologies from the R&D centre there. And Paul started his career in the steel industry before moving into automotive with Chrysler's material engineering and Ram truck body engineering. And later at GM, he headed the manufacturing engineering team around critical stamping and complex structures. So, Paul, I think you tick all the boxes in the experience that we need to feed into this. Our other presenter is Jérôme Favero. Jérôme is no stranger to working with AMS. I've spoken with him and interviewed him several times over the years. He's head of Automotive Steel Solutions at ArcelorMittal's global R&D. Jérôme's worked there for the last 11 years. Today as head of Automotive Steel Solutions. He's in charge of pilot engineering, global R&D activities for generic automotive solutions, customer support, including sustainability and additive manufacturing. So we might get Jérôme to be able to talk a little bit about that later on, if we're working okay. Jérôme and Paul have both got short presentations they'd just like to deliver prior to us getting into the discussion point. So I'm going to ask Jérôme to get started on that, if you will. So yeah. Jérôme is presenter, and we'll pop back when Jérôme has finished this with Paul's. Thank you.
Okay, I suppose you see my screen?
Yeah, it's all there.
Yeah, okay, so good morning, good afternoon, everybody. Thank you for joining this live stream with us today. So I'm Jérôme Favero, and I'm head of Automotive Steel Solutions at Global R&D. And I'm glad to present you our multi-part integration approach. It's a new approach we have developed at ArcelorMittal for the car industry. So basically, I would like to start, in fact, with the different new trends which are currently driving the innovation in the automotive industry, which are the simplification, the modularity, the electrification, and the sustainability. In fact, with our steel solution at ArcelorMittal, we wanted to bring new answers to the challenge which are connected, in fact, to these new trends. And this is how we developed the multi-part integration concept. You can see on the picture on the right-hand side what is behind this concept. In fact, the idea looks pretty simple. The idea is to integrate into only one part a high amount of stamped parts. So this is in fact possible thanks to the laser welded blank technologies and also the intensive use of press hardening steels, because they allow to have a very complex shape, thanks to a very high formability of these grades, and also to combine different mechanical properties to have different crash function, I would say, on the same parts. So thanks to multi-part integration concept, in fact, we are able to propose to the car manufacturer an additional added value in addition to the standard, I would say, crash resistance and mass and cost savings. So if we focus on the HRM and if we look a bit more about these values we can bring, you can see on the table on the left-hand side a kind of most interesting facts and information about this concept. So first of all, as already mentioned, we can integrate 11 parts into only one. Thanks to integration, we are able to suppress 136 spot welds for this area. Thanks to the new press hardening steel grades here compared to the reference, our benchmark reference, we can also propose 10% weight reduction. Now, if we look a bit further, and if we think about the manufacturing operation, I think that one of the very interesting points is that we are able to save 29% in capex in a case of a greenfield plant, for example, to start the production or the industrialization of this scope. In terms of CO2, there are also some interesting savings. First of all, thanks to the lightweighting potentials of the press hardening steels, but also to the nesting optimization, which is possible with laser welded blanks. In other words, we are able to reduce the gross weight, gross material consumption. So this is why we can achieve 18% of CO2 savings, and it goes up to 27% if we consider the new usable 1500 product with high recycling content and renewably produced, our X-Car brand. In terms of hour of labor per vehicle, which is also something very interesting to understand how effective could be as a production, we are able here to reduce this amount by 40% at the rear module level. And we have, of course, also some very positive impact on the workshop area. So, but before making this very deep analysis of the impact of the headframe on the assembly sequence, it is first of all important to design a reliable and a very performant design to be able to answer to all the crash requirements. And this is indeed what we did. You can see on the left-hand side a simulation of the real crash and the behavior of the headframe. And you can see that thanks to the combination of different press hardening steel products, so on the orange you have the ductible, so product with high ductility to absorb the energy in successive folding, and on the left-hand side in red the usable to I would say resist to the intrusion and propose, by the way, a good anti-intrusion function. So once the concept is designed and optimized in terms of weight, of course the formability is checked, and here in this case we went up to the prototyping phase to demonstrate the feasibility of the concept. What is also important to keep in mind is that these parts are very large, and here we work together with some car manufacturers, tier ones, but also major suppliers of the hot stamping lines, in order to ensure that our concept is indeed compatible with current assets and existing lines. We focused today a lot the discussion on the headframe, but we extended this approach to a full body in white, and you can see on the left-hand side the different MPI we have very deeply investigated and with a very special attention to their impact and to the assembly sequence. And you can see on the right-hand side even other alternative solutions which have also been validated in crash, knowing that ArcelorMittal teams are of course ready and to support the car manufacturers to introduce this concept and understand the benefits which could be offered in a customer context. So in a nutshell, it is what I wanted to share with you as introduction, and thank you very much for your attention.
Thanks very much, Jérôme. That's really interesting stuff. I mean, we're going to touch on a few of those topics in a little while after Paul's presentation. But some interesting things there on sort of the simulation around steel performance and the actual designing and manufacturing of some of those structures. But without any further ado, I shall let Paul jump into his presentation, and I will catch up with you in a moment. Thanks a lot. Take it away, Paul.
Okay. Thank you, Nick. Okay, and good morning, afternoon, and if anybody is on from Asia, good evening. So you'll probably hear something very similar in my discussion here. This is what Jérôme just talked about, but maybe set the foundation first. You know, Gestamp is a Spanish-based but multi-international company with production plants all over the world. Basically, wherever automotive OEM production is, we have a facility. We try to team up with our partners and the OEM customers to be really close to them from a footprint standpoint. And along those same lines, we have a global R&D network that's interconnected. I'm in charge of the North American R&D Center, but this map that you see here is a very interconnected network where we bring in innovations to the automotive market. We share technologies from region to region. And the important thing is we're close to the engineering homerooms of our customers so that we can work together in developing solutions that provide good value to them. So the theme that we'll talk about, sustainability, safety, lightweighting, some new products specific for EV, but maybe not just for EV. And then Jérôme kind of touched on this. You know, one thing that we're really hearing from our customer base is ways of making their operations simpler and reducing the assembly time within their plants. And so we have a whole suite of innovations that we are bringing to the market, where a part consolidation again is echoed strongly. They can be either laser welded or overlap patch blank, large giga stampings, if you will, from door rings, door frames, one-piece floors, rear rail systems, front rail systems, roof rings. A big portion of what we're trying to do and where we see the trends in automotive coming is to strengthen the body structure so we can simplify the battery enclosure. Right now, let's say the first generation battery enclosures, they're very complex from both a design and an assembly standpoint, and that complexity results in a lot of cost. So where we see the market going is to try to simplify that enclosure and moving some of the responsibilities for a crash into the body and away from the battery enclosure itself. So reinforcing that body in white, simplifying the battery system. And then along the lines, as we get into the EV structure, the applications of chassis is changing. In the past, chassis was pretty much responsible for durability and for the dynamics and handling of the vehicle. And now it also has to play a role into the crash and torque of these large, high-powered electric motors as well. So we see all this going together in terms of the trends and where the battery technology is going, cell to vehicle, cell to chassis, cell to body. There's different names, but very similar techniques where we're trying to maximize the space for batteries to have that longest distance between charges possible that the OEMs are driving for by really enforcing that body structure in a very cost-effective manner. And so we'll talk more about that in a little bit. Thank you.
Thanks, Paul. Some really good points there. And as Paul said, we're going to be picking up on a few of those as we go through this afternoon's session. Thanks, Jérôme, for joining us. Just a quick note to the audience. Both presentations are available as a PDF in the handouts box. If you look in there, you can click on them, download them, have a look through them again. But we're going to cover off a bit more stuff now. One thing before we jump into our session, just wanted to bring to the attention of the audience are the AMS North America event. Quite excited about this because it's, I think, the first time in about 10 years we've done a live event in the US. So we're really looking forward to getting back there. As you can see, October 16th and 17th. If you click there, there's a link, I think, in chat box for you, and also you can click. There's a QR code which apparently does miraculous things and takes you to the registration page where you can find out more information about the event and the agenda, and if you wish to register. So it'd be great to see you out there in October. But now let's get to why we're all here this afternoon. Let's get on to the discussion around these electric vehicle architectures. Great points made by both of you there. Lots to sort of talk about, and it's quite a moving feast at the minute. It's not a fixed thing at the moment. We keep seeing different platforms coming up. It seems like the life cycle of the platforms has been quite reduced at times as well. It might be lengthening a little now, but I mean, in terms of the vehicle trends, what do you see some of the, working with your customers, what do you see some of the biggest challenges in relation to production are? I mean, materials choices, volumes, they're trying to meet compromises or optimize all of those things. Can I come to you first, Paul? Where do you see sort of the biggest challenges for the car makers and your customers in relation to these structures and what they're trying to optimize?
Yeah, so I think, when it comes to the vehicle structure, the change from having the engine in the front to having a very heavy battery, in the floor, the load paths have to change, how you design the vehicle, the dynamics, and of course the crash management really changes, right? You have to, for side impact especially, you have to absorb a lot of energy in a very short distance. So a lot of the OEMs, and let's say this first generation EVs, they're using a lot of aluminum extrusions, both in the side structure to absorb energy in a very short distance, but also in the battery trays. Those first generation battery trays, probably the OEMs didn't know exactly how to design it, what they had to protect for, what the duty cycles were. So again, they tend to be very complex, aluminum extensive, and that really drives some complexities in the automotive market from the standpoint that there's not a lot of aluminum extrusion capability of automotive grade. So that's a supply chain issue. And then you kind of couple that with these new EVs. There's no track record, so we're not exactly sure how they're going to sell, what the demand is going to be. So volume uncertainty is an issue. So we've got these multitude of complexities going on from new materials, new designs, complex designs, and a new world that we're not exactly sure, how to track it, how to trend it.
It sounds like a bit of a perfect storm. I mean, Jérôme, what's your view on this?
Yeah, I think that first of all we have to keep in mind that the market is changing, or it will change very soon. So we see the progression of EV sales. We know that now in Europe, EV sales account for approximately 13% of new vehicle sales, and it will continue to increase. We will see the same trend in other areas. So in one moment, it means that competitiveness and costs for BEV will become more and more important. And we can see also the situation about BEV in Europe. And we see, and with what we see in the news, we understand that it's absolutely a key point. And here, my point is, on one side, we have a need for competitiveness. On the other side, we have the technical aspect of BEV, for example, lightweighting. Lightweighting is still a topic for battery electric vehicles because we still have some gains in the range, and of course, in question of car handling and dynamics, the lighter the car, the better, of course. But nevertheless, that pressure is getting down compared to previous design requirement with internal combustion engine. Somehow today, I would say that with that limited pressure on lightweighting, there is likely a large place for advanced high-strength steels and press hardening steels. Now, if we look at other points, and likely to come with the legislation to come, especially first in Europe, but in other areas are also some thinking about it, and more especially in China, about life cycle assessment. Sustainability will likely become another key driver for the material choice in the future of electrification. And here again, I think that it's a second aspect strongly pushing for steel. It's true that today, as Paul mentioned, there are a lot of, not a lot, but some application in aluminum extrusion, especially for the worker area. But I think it was also a question of hurry in the development, because if we take time to design a steel solution like we did in our generic project, we see that we can start to be very competitive in terms of weight without having problem of the hybrid assembly. And by the way, that push the cost of the aluminium solution or the weight saving proposed by aluminium very, very far. So this is why today I think that steel is really in a good place to answer to the next need of the battery electric vehicles. Yeah. And then I think a last point is maybe also in the production. As we discussed a lot, again, competitiveness will start to be a very key word for battery electric vehicles. So here likely there will be some place for material innovation also impacting the production lines. So it's more or less the view I have on materials and on the electrification.
I mean, you raised a good point there. The actual life cycle of the vehicle that now has to be built into the design. I mean, that's arguably it's been there, but it's now moved up the list of priorities towards the top now. And as you said, and it's interesting listening to both of you that there are, as Paul said, and you both said, a numerous number of challenges facing car makers to get those volumes of cars out there in a economically viable way. So there's that challenge. But what you've just explained to me as well is that they have a wealth of validated, proven technologies and materials to work with now. So you can see competition hotting up as to which material they're going to use. We might come on to a little bit of that mix later on. But they do seem to at least have the tools and the solutions there to overcome a lot of the challenges that we were discussing there. I mean, a lot of it obviously will come down to cost, time cycle, time, things like that. But it's an interesting context you set there. That's a good. So all we've got to do now is solve all those problems in the next 30 minutes that you just outlined there. So no pressure at all. One of the things, just leading on a little bit from this, I think both of you, when I've spoken to you separately, you've mentioned this, with this sort of continuous development of EV platforms, is this putting pressure on time to market when you're working on projects with clients, with either tier suppliers or with OEMs? And how do you both come from companies that have very strong methodologies and validation programs. You've been working in this industry for decades. So how do you operate when those timescales become constrained? So I'll come to Jérôme, back to Jérôme on that one, I think, to start with. Oh, sorry.
Well, on our side, I would not say that we saw a high difference. I think that there are some different strategies depending on the car manufacturer. Some jumped very early in the idea of having a very dedicated platform for electric vehicles, and others make the choice to have, I would say, multi-energy or hybrid platforms for different powertrains. And I think that was one of the strategy, in fact, to speed up a bit the development time and be ready as soon as possible, I would say, with car in the market. However, I don't think that it put a lot of pressure on the safety and the validation of the cars. But on our side, regarding the materials, we saw clearly difference in the request for approval and for technical validations. But we kept the same standard as usual, and we kept, I would say, the same testing, as that pressure was not really to be felt here.
And Paul?
Yeah, maybe I'll add just one little tidbit. One of the things that we're seeing with the newer EV OEMs, they're really disruptors. And one of the ways that they're disrupting is their speed to market, much faster than let's say, the traditional OEMs. And now we're seeing those traditional OEMs adjust their vehicle development plan to match that. So, it's easy to say, okay, shrink it 30%, your vehicle development. How do you do that, right? And I think you kind of hit on this, the validation, and it's really the virtual validation that's really coming into play. Now, again, virtual validation has been around for a long time. Now you're just relying on it more and more to help develop that speed that, these OEMs are following. So, making sure that we really characterize the materials, characterize the assemblies, and even characterize the production process, right, in a virtual setting before you start building tools is really key right now to trying to get that speed to market down to where they're trying to achieve.
And you touched on an interesting point there, like the virtual validation. I mean, digital tools, thank God for them, because they are the great enabler of things at the moment and are helping to speed things along. But I just wondered, I know, again, sort of speaking with tier suppliers, that over the last 5 years, maybe more, especially with the transition to EV, the working relationship between suppliers and clients has become much more technical partnerships, a much closer partnership where it's not just supplying a part or a material or a bit of equipment. You're becoming much more embedded in the whole design and development process of a vehicle, much further upstream. And I'm assuming, is this kind of wider, I'll use one of the terms I use 50 times on a page, digitalization of processes. Is that bringing you much closer to your clients and much more enabling you to operate much, as I said, further upstream in that vehicle development process? So back to you, Paul, on that one.
Yeah, and for sure, we have to get involved earlier to hit the speed that we're trying to hit, and we have to do that with doing all the virtual validations. So for us, as stampers and assemblers, right, we have to validate that process. We do a lot of forming simulations, and we have to make sure again that the material cards that we use accurately represent our production process. And so, we're getting involved earlier. We're getting involved to provide that DFM, that design for manufacturability input, much earlier into the vehicle development plan. And again, that's a critical piece to making sure that you reduce the speed to market. So yeah, we are seeing that more and more.
And Jérôme, is that the same for you?
Yeah, same for us. But on the other hand, I would say it's not really new. It's not really new. I would say the design and the development of the car is digital since already years with the different software lines. And here, of course, it's key for us to develop the right material cards to be able to compute, in fact, the behavior of our materials. And here we also invested a lot internally to improve, in fact, the way we are doing the testing to propose data which are very reliable. But I think that one point which is interesting is also now the new developments which are starting, and that we also run internally at ArcelorMittal, in order to be able to design from the early stage, depending on the stakes. do we want to have a suit optimized design? Do we want to have a mass optimized design? Do we want to have a cost optimized design? And thanks to some interesting approach based on digitalization, we are able to have a very much more efficient design approach to target much faster, in fact, the target we set it with our customers. Yeah.
That's interesting. And Paul, is that something you see like a breakdown of like targeted development around a particular vehicle? I'm assuming it goes around vehicle segment and sort of cost base is around that.
Yeah, absolutely. I mean, from the beginning, some OEMs on certain vehicles say this is going to be a cost-conscious vehicle, and so we really got to keep in mind, right, the material selection, the assembly process selection has to have that in mind, that cost. Other vehicles might have a little bit more, you know, latitude to whether it's paying for weight savings or paying for performance, right? And so you can offer different solutions, whether it's materials or process. But we definitely see that from the beginning. We have an idea, you know, is this going to be a cost-conscious car? Is it going to be a performance car? And then we set our targets accordingly.
Yeah, interesting. I think cost is good. The word cost is going to come up quite a bit this afternoon, but there's no magic wand for that one. Just moving on to the vehicle platforms themselves. One of the things we saw was the development of, again, it's cycles of news from our side, but is the sort of adoption and development of skateboard platforms. And we saw a lot of those being developed by non-car makers as well. So I won't say they were simple, because they are all complex engineering things, but from a point of view that not having to build a body, which is a very complex job, the skateboard platform seems to offer a lot of flexibility in terms of wheelbase, track, the battery density. It seems on paper a very attractive proposition for the vehicle maker. But then if you look back, then you then have to have the body that still have to build the body, and it still has to marry to that platform afterwards. And that almost seems like going back to the old body on chassis designs, you know, way back when kind of thing. So it's an interesting sort of a development in the car industry. Do you see them as even though they seem simple, as creating more complexity for vehicle makers who have been used to building unibodies in, you know, the millions? So Jérôme, what do you think on that?
Yeah, I think you ask, in fact, a very difficult question, because for passenger cars, I would say that it's very difficult, I think, to find somehow the right balance between a platform approach and somehow a very sophisticated design, very, I would say, adapted for cost and weight optimization. So where is the optimum, I would say? I think that it's a very difficult question for passenger cars, and I think that the context is bringing also a lot of uncertainties in the question. It depends if you have greenfield or brownfield operations. So I would say that for passenger cars, that question is very tricky, and I'm not able, in fact, to bring any clarity on it. However, I think that for vans or for last mile deliveries, where we are requesting to have a high versatility between the different models, this approach makes likely a lot of sense.
Yeah, I mean, the LCV side really seems to have taken off. We've seen a lot of guys, even the big guys, even the bigger car makers, are now sort of latching onto that with platforms that they've invested in, or they're building themselves. It does seem to be the potential boom market. We keep hearing about big orders, and see how they transpire. But Paul, what's your view on that?
Yeah, well, I think the point that you guys made, Jérôme and Nick too, on the vans, right? Skateboards make a lot of sense for that, and you can scale that. But I think what we see in some of the newer OEMs, that the newer EV OEMs that chose the skateboard style, might have done it more for a business reason, where, you know, that's their technology, that's their IP, and they have the ability to build a lot of them. But then when it comes to the vehicle, basically the top hat that they put on there, you know, there's maybe a limited number of sales that they can get. So, you know, I know one of the new OEMs, EV OEMs, you know, they want to build vehicles for other OEMs with their skateboard technology. So that's more of a business decision. But what we're seeing with let's say the legacy OEMs, as they really dive into EVs, they're not really going that way. You know, they're building very specific, you know, unibody vehicles that can handle the structure for these EVs. So we're definitely not seeing everybody adopt it. I think there's going to be some pockets where it makes a lot of sense, and there's going to be some, you know, a lot of the wide margin that probably just maybe doesn't make as much sense to go with that style.
Yeah, it's an interest. It's a very interesting one. I'm watching it with great interest to see which way it goes. I mean, the unibody makes perfect sense because you're already set up to build those things, but they are ultimately, there are complications in basically integrating the motors. You mentioned the structures there without the engine being there. Those crash structures need to change, and obviously the floor, the battery integration, which we'll come on to a little bit later, is another kind of development which raises challenges. And Jérôme, you made a very interesting point there, and one which makes our discussions this afternoon probably that bit more complicated. You said it's very difficult to know what is the optimum. Even the car makers don't know what the optimum is, and absolutely right, absolutely right. I mean, you know, there's all the work we see with you guys and around, but it's striving towards this kind of optimum. But where is it? Where do you sort of stick a pin and say that's as good as it's going to be? Just moving on to some more new developments, or relatively new developments, certainly for the automotive industry. Gigacasting and gigastamping. Everything has the word giga, mega, something stuck on the front of it. But these are really interesting. We saw it with Tesla. I think we recognized it first with Tesla. I know Volvo picked it up. I think Mercedes are doing something similar. So essentially using large cast components, which is unusual in the floor sections or the rear and front and rear sections of a vehicle, and with a view that when we spoke to Volvo about this, was that it was simplifying operations for them. To me, it looks like a very complex process, but the process I know has been enhanced so you can produce those kind of castings now with the correct specifications, and by extension now with steel, doing these very large stamped parts, again offering another opportunity or another option to vehicle makers. Is that let me ask this question. If it wasn't for electric vehicle, the development of them, would we not be seeing this being introduced into vehicle platforms now? Is that a valid question? Because I think to myself, it's obviously, you know, challenge is sort of the mother of all invention in a way. You are looking to innovate and to drive something. And I'm just interested to know whether this would have actually come to pass without electric vehicles. So I'm going to go to Paul on this one. You both look like you don't want to answer that question. Yeah.
So one of the things that the OEM industry does really well is benchmark, right? When these vehicles come out, they benchmark each other and they continuously improve. And you kind of mentioned it, right? Tesla was the first that really announced the gigacastings, and I think a lot of people are benchmarking that, right? And they're looking at it, trying to understand, you know, is that the right value proposition that they should do? And I think we definitely see some OEMs heading in that way, at least to some extent. As an engineer, gigacastings, aluminum gigacastings, I mean, it's great, right? You can make it extremely stiff, it's very lightweight, you can make it very performance oriented, but it comes at a cost, and then the repairability question is always out there, right? I don't think that's been really figured out yet. And so I think, you know, both what Jérôme talked about and I talked about, you know, there's other alternatives out there that kind of accomplish something similar, right? We're talking about simplifying the body construction process by part consolidation. And so, you know, gigastampings, you're using existing assets, right, to help keep the cost down. It might be a very attractive alternative. That's something that, again, we're at Gestamp, we're really involved with our innovations in developing a whole suite of giga stampings, and I think you'll start to see that proliferate more into the market here in the very near future.
And Jérôme, do you agree with that? I mean, I was going to ask the question about where do you think it might develop. So.
Yeah, I fully agree with what was said. So it is definitely now a trend. As I mentioned, design for manufacturing approach, let's say, will be more and more now used, and we may now think more about the potential manufacturing optimizations through design. It's true that electrification opened a lot of doors. Why? Because first of all, it's an opportunity to rethink the body in white without having a strong legacy, I would say, from the internal combustion engines. And on the other hand, we have also a lot of new EV companies. That's why it's like not a new EV companies, but at least it's greenfield based, and which makes that there is room for very, very innovative and disruptive processes. So definitely, battery electric vehicles are a good context for that. However, indeed, there are different solutions, as explained on my side. Also in the introduction at ArcelorMittal, we have the MPI proposal, and here at the whole body in white level, for example, we can reduce the part count by 46 parts, which allow also to suppress 50 robots. So somehow it takes also the same direction as the claim of mega casting. But it's true that the part integration, to be honest, is not at the same level. We cannot compete, I would say, with the 2D based geometries. However, I think to draw a full picture, as there are a lot of points, and material cost, process costs are clearly in favor of very large stamped parts. We spoke about lightweighting. Lightweighting, as mentioned, for battery electric vehicles is nevertheless still important, even if the pressure is a bit down. But now, thanks to the different benchmarking companies which exist, we know that the very large modules in high pressure die casting are heavier compared to steel structures. So definitely this is here not a good point. So repairability is of course also questions. And again, sustainability is still a very important point, and will become more and more important. And here, with all the scenarios, we consider there is no way, in fact, mega casting can be a sustainable solution compared to steel design. Even if we consider decarbonized scenario and all the recycling, which we can apply to this approach. So this is why I'm pretty convinced on my side that this trend will continue, because again, we have mentioned in the beginning of the discussion that the competitiveness between EV manufacturers will for sure increase. And so they will be motivated to look for all the possible savings in operations. But then, to my personal opinion, it will continue toward very large steel parts rather than aluminium high pressure die casting.
It's an interesting one. I mean, I've heard lots of sort of contrary arguments around it, but I mean, it seems to be. I mean, you guys obviously with the you mentioned it there with the gigastamping, are taking this in a direction where it's, you know, you're broadening the scope of what it can be applied to. What are the limiting factors? I've got a question here around gigastamping in terms of design that you can use it for. I don't know. I'm gonna leave that to you. What are the sort of limiting factors at present? Question not. So Paul, I know you think. Yeah, can I go with Paul first on that one?
Yeah, sure. So again, one of the things that we want to make sure is we can use our current assets. So the size is going to be, you know, one of the limiters, right? We can't go a full vehicle from bumper to bumper. Our assets really just aren't set for that, and we want to keep the cost structure down. So we want to reuse the assets. So door rings, possibly even double door rings, you know, that could fit within our asset category. So we can fit a lot, but not the whole vehicle. So that's going to be one of the limiters. And then I think Jérôme touched on it too, you know, 2D versus 3D, right? I mean, with the casting, you can put ribs wherever you want. You can put a lot more shape. With a stamping, it has to be fairly, you know, open. Obviously, you can close it out and get some box structure that way. But it is a little bit different from a performance standpoint. But then again, it's going to be, you know, you get the cost value, you got the sustainability, you know, value. So there's some, you know, pluses and minuses on both sides of that equation.
Yeah. And we're going to probably, again, that's probably going to go down to market segment and cost and what they're willing to spend. I guess the cost sensitivity we mentioned earlier on is going to play a factor in that. There's a question here from one of the audience, but I'll put my question first and I'll follow up with this one. Multi-material structures, again, as journalists, we have a cycle of every few years we ask this question about certain things, because we keep saying, you know, carbon fiber is going to be the latest thing, the joining technologies are there. But when we were ticking off the tick box of what car makers are looking for from their vehicles, this optimum, do multi-material structures, not just the whole body in white, but things like the battery enclosure, to some extent the sort of front and rear subframes, all those kind of things, is multi-material the optimum in terms of kind of weight reduction, strength, performance, flexibility? I'm not sure there, but or are the production things still a challenge, or is it cost? I mean, get back to cost again, I think. So, Jérôme, can I ask you on this one? I know you're a steel man, but what's your opinion?
Yeah, sure. But anyway, again, if we look at the context of EV today, I would say there are three main points. The first one is lightweighting pressure, which is down. Second point is sustainability. Third point is costs. So if we look at the combination, I would say use advanced high-strength steel or press hardening steels. Why? Because if you use a hybrid design, you would need to cope with the complexity of the assembly. This is feasible. There are plenty of solutions, but it's also one limiting factor. So if you have on one side a context which is not very favorable or very of materials with pretty high lightweighting potential, but at a very high cost or very high CO2 emissions, today I don't see a lot of room for multi-material assembly in the body in white.
And Paul, your view on this? I think I know you mentioned to me in the past cost is a factor in multi-material.
Yeah. So I think it gets back to the vehicle, its cost targets, its market penetration potential, right, of what it's trying to achieve, whether or not it can afford. For sure, multi-material, it can do some really good things from a lightweighting and a design standpoint, but there's the cost of sustainability that's the negative to it. So it gets down to what's the targets for that vehicle. I think if you look at what a lot of the OEMs did, again, speed to market, get there quicker, that steel structure to absorb a lot of energy really quick, especially with the new IHS regulations we have in the US. Aluminum extrusions was a very quick answer and solution to that. But again, it comes at a cost, right? And so, Gestamp, we have what we call a wave rocker design, which is like an egg carton type, design to absorb a lot of energy with either hot stamping or advanced high strength steel hydroforming at a much lower price point. It comes down to almost weight parity. But it took a little while to develop that innovation. It wasn't ready, when the first solutions were required. So I think you're going to start seeing a lot of competitive solutions, based on what the industry innovates. But I think long term, again, it's going to be more of the higher priced vehicles that really need to afford or can afford for that weight savings to go that way.
Yeah, I'm assuming on localized structures within the car as well, where it needs a specific performance requirement. An interesting comment from one of our audience asking about the fact that the variety of multi-material components then need a bigger range of joining technologies to assemble them, and asking, is that this kind of a limiting factor on them? And I'm sure the comments you've just mentioned there, when you look at it in the context of the theme and the thread of simplicity or simplifying structures, then yes, that then I'm sure becomes a limiting factor. Even though it is successfully deployed, with adhesives and rivets. I was at Jaguar Land Rover last week and looking at their aluminium bodies in white. They use rivets to join together. They do it successfully on a large scale body in white in reasonable volumes as well, and they have been doing that for quite some time. But again, they're in a particular market at a particular price point. So yeah, it's one of those ones that's kind of in about an interesting sort of point from the audience on that. Well, we kind of covered off on this, but I was going to ask, do you see an increase in non-weld joining methods being used? I won't say across the entire car, because we know certain cars use adhesives. Even with spot welding, they use adhesives to put the side framings on. So they're not unusual to use that in sort of high volume. But do you see slightly more of it? And especially around battery enclosures, I would suggest, is where we're starting to see more liquid fixing, shall we say, in that respect. So maybe that's a little bit of a cheat, but across the body structure, what do you think? Do you think, again, we're going to see a slight move towards some of these alternatives, or spot welding is still spot on, basically? So Paul, back to you on that one, please.
So let me separate the discussion. As far as adhesives goes, you know, for over the last, let's say 20 plus years, I think the use of adhesive has been steadily growing, both, you know, in steel structure as well as aluminum and multi-material. When it comes to non-spot welding joining methods, whether it's MIG, laser, clinching, riveting, I think that goes with the same discussion as multi-materials, because it's usually those multi-materials that's driving that, right? And so it might be a quick, easy solution, you know, that you have to have, and therefore you have to employ those joining technologies. But longer term, we think for sustainability and cost reasons, it's probably going to go back to predominantly steel, and spot welding is the least expensive way of joining steel. And so that's probably what's going to happen. But again, that's what the crystal ball says today.
Yeah. And Jérôme, do you concur with that?
I fully agree. Nothing to add.
Because I was thinking, if you think about, I mean, not on the EV side, but if you think about like laser brazing, so roof panels, we started to see a lot of seam welding because they perfected the laser brazing. I've seen it; it's very clever with very little splatter and, you know, very little finish on it. That's an aesthetic thing, and again, probably at a certain price point. But I was also thinking around the battery enclosures themselves, because in the old days, race car shells that used to seam weld the race car shells to stiffen them up a little bit. And I just wondered, with the battery structures requiring that degree of strength, has seam welding seen an increase in those structures, or is it down to the design of the structure itself and its materials rather than the joining? So back to you, Paul, on that one, I think.
Okay, so, you know, for sure, seam welding is increasing in battery structures. Again, that first generation battery structures being a lot of aluminum extrusions, and you have to MIG weld or mag weld those, right? There's been lots of discussion about laser welding, but the leak-proof requirement of battery enclosures is so high. It's difficult for anybody to rely 100% that you're not going to have a pore, a porosity, some, you know, a leak potential on laser welding, and I think the industry's been really hesitant to go all in that. Now, if they can develop a system with all the vision systems to make sure that you have 100% good weld, maybe that'll change. I haven't seen enough evidence yet to say that there's enough low risk to go that way, but maybe in the future there will be.
And Jérôme?
Yeah, I have same point. I think that water tightness is absolutely a key topic, and that's a strong motivation for white seams indeed.
Yeah. I'd throw that one in, because seam welding is something, you know, sort of knocks about in the backyard of things. But I was quite interested to see if it was being resurrected in anything beyond welding old shells together. Just coming on to a point now, Jérôme, when I was in a discussion with you a few weeks ago, you mentioned additive manufactured parts potentially being used in vehicle structures. I know there's not a lot of detail, but could you elaborate a little bit on how and where they might be used and how they might be produced? Are they cast? Are they?
I think that it's an interesting topic and very innovative topic. So as additive manufacturing, I would say we can separate powder-based part and wire-based part. For powder-based part, let's say that today we do not see any short to mid-term applications for different reasons, one being the throughput and the cost, I would say. However, wire-based solutions are much more attractive because the deposition rate can be already pretty high, the investment pretty low, so it can be good solutions. And here we spoke about the difficulty to find an optimum in the platform between the high complexity, I would say, of optimized car and the platform idea to achieve scale savings. If we look at some car manufacturers, they do have similar platforms for two cars having more than 1 ton of weight difference. So you can imagine that in case of crash, you will have somehow to adapt the scenario, because very often the lightest car is a kind of mass market, so it should be more optimized because it's a, I would say, the big runner. But in one moment, for the largest car, you need somehow to reinforce the structure to keep the same crash requirements. And that's here where additive manufacturing could play a role by printing some insert, for example, like we can find today in plastic, for example, to reinforce strategic area, in fact, the body in white of the high-end car. And in fact, if we look at the cost structure of this kind of solution, it's pretty positive, because on one side we have high-end car, so it means a higher amount of possible money spent per kilogram saved somehow, and on the other hand we have a pretty low volume. So there are a good context for additive manufacturing, wire-based. It's true that the technology has still to evolve, but today I think there are all aspects saying that it could be a good solution in midterm.
And Paul, what have you come across this idea or this sort of application of additive parts?
Yeah. I guess our view on additive manufacturing is going to play a really significant role in tools, more so than in parts. In parts, we really think the volume's got to be low. It's going to be ultra premium niche vehicles. Hard to see it having the cost scale that you would require to put it into high volume production.
Yeah. We're coming to the end of the session, but I just want to sneak in one last question for you, because I've been really keen to get some feedback on this one. So I'm just going to skip the end. A lot of manufacturers are starting to look towards battery integration in the vehicle, cell to chassis or shell to body, removing the module side of it altogether. So essentially, I'm guessing directly putting the battery cells into what would be the floor pan of the car, and obviously the floor pan of the car is engineered in a certain way. So creating the entire floor pan as the battery pack, not something that's inserted or something that's a separate thing. One, are you working on some projects around this? And two, what are your views on it in terms of feasibility, timeline? It does seem to be going ahead, from what I understand. Paul, what's your view on that?
Yeah, we definitely see the trend. We definitely see the trend of going more to cell to vehicle, cell to car, cell to body, whatever you want to call it. Again, what we think is the body structure is going to get taking more of the responsibility for crash. So it's going to be, let's say, reinforced even more. And a lot of our innovations are driven to help enable that reinforcement. And that the battery structure is going to become less complex. So the total system cost is going to be reduced with that approach. And we think that that's going to continue. There's still lots of, let's say, questions on, how would you repair it? How would you service it? So I think there's still some questions out there that maybe hasn't been fully answered, but we definitely see the trend going in that direction.
Yeah. And Jérôme?
Yeah, indeed, there are indeed good drivers. So again, simplification of production, simplification of parallel function, for example, battery frame, worker reinforcement. But nevertheless, indeed, there are a lot of criteria to be considered. So on our side, we have also some R&D, and we investigated some concepts. But then, depending of the importance we put on one or the other criteria, one or the other concept have to be chosen. So I think there are still a lot of uncertainty on it, because of course, crash and VH, but assembly sequence to be resynced, readiness, how to integrate a codec system. Very important, repairability, accessibility. As Paul mentioned, there are a lot of open points which are strongly driven the design freedom you have. And I think that, again, one very important point will be the possible evolution of the legislation about circularity and also repairability of EVs.
Yeah, I think recyclability on cars with batteries.
Like that be one approach, yeah.
Yeah, I think we heard that was one of the concerns. We spoke to some of the battery recycling guys, and they were saying that could be a challenge with the entire body in white essentially being the battery pack. So we'll see how that one plays out. From an engineering point of view, really interesting. I'm very interested to see the structures that you guys designed to match all those criteria. That's going to be fascinating, and also the assembly process as well is just going to be really, really fascinating. That brings us pretty much to the close of our session. Thanks, Paul, Jérôme, for your comments, time, insights. Really appreciate it. It's been great talking with you. thanks to our audience for joining us. Just want a quick reminder about our North America event. Yeah, banging on about that again, but it's really worth having a look. Obviously, North America is actually, if you look in the news, it's really taking off. A conversation that I had with Paul the other day about the IRA, the Inflation Reduction Act, that's really driving a lot of investment over there, really supercharging it. So obviously that's going to be coming to the fore when we're over there chatting with all the tier suppliers and OEMs to figure it out, but also to see how kind of the birthplace, if you want to call it that, of modern high volume car production, see how that is adapting and pushing its way through to this transition to e-mobility. So please, you'll see the register there, there's a link in there now. Please have a look, and if you like what you like and you're in the area, we'd love to see you, catch up with you. We also have another live stream coming up on the 10th of May. This one is on battery production. So we're going to be looking more in depth at cell production and integration. There'll be a little bit of crossover on what we were just chatting about now, actually, and how that's all going to work. Strategies, chemistries, volumes, how do you ramp it up? Maybe a little bit about the geography of it, where that might happen as well with our panel. But you can look forward to that. And again, you can register. The link is there in the chat box. So again, love to have you join us for that. So, and also this live stream session will be available on demand, probably in about 24 hours. It will be on the website. So if you haven't had a look or you'd like to listen again, please register and have a look at that. Thanks to everyone who sent questions over. We didn't have time to go through all of them, but we'll pass on all your comments and questions to the teams at ArcelorMittal and at Gestamp. And with that, thanks to, again, our partner ArcelorMittal for this, and been great to be with you. From me, that's goodbye. I hopefully see you soon.
Thank you. Bye.
Bye.